In this video, we have taken a topic about ray diagrams for concave mirror. So first, we have to understand about the basic rules which are required for different cases of concave mirror. So let us have the first rule. In this first rule, we need to draw a ray diagram first. See here, we are drawing a concave mirror. The bulge out surface is the non-reflecting surface and the bent in surface is the reflecting surface. If I extend this part, which becomes a sphere, means this mirror is a part of the sphere, I can get the center of curvature for the mirror. This point represent pole and the midway between C and P represent the principal focus. Here X and X dash will act as the principal axis, and this one M dash is the mirror. Now first rule is that when a ray of light parallel to the principal axis getting incident on the reflecting surface of the mirror, after reflection it passes to the principal focus. So this line represent incident ray, this line represent reflected ray. Now I can draw the angle of incidence. This dotted line represent an imaginary line which is passing through the center of curvature. So here the angle is angle of incidence, here the angle is angle of reflection. Now let us write down the first rule. Here the rule is that when light ray incident to the concave mirror and it is parallel to the principal axis, after reflection it passes through the principal focus of concave mirror. So this is the first rule. Now let us have the second rule. First I need to draw the concave mirror. So here is a concave mirror. Now if I extend, I can have the location point for center of curvature. This represent pole and the midway is principal focus. X dash is your principal axis. Now the rule is that when a ray of light is getting incident on the reflecting surface of concave mirror is which passing through the center of curvature, after reflection it revert back on the same path. So that is the rule. Here the angle of incidence and angle of reflection is 0 degree. So this particular ray is acting as incident ray and the reflecting ray is here, it is reverting back through the center of curvature, that is the reflected ray. So I will write down here that when the ray of light passing through the center of curvature after reflection it revert back on the same path. Now let us move on to the next rule. We have rule number 3. Rule number 3 is, for that we need to draw the basic ray diagram for concave mirror. Here we have the concave mirror. Extend to a part of sphere. Locate the center of curvature. This will be the principal focus, and here it is pole. This x and x dash represent principal axis. The rule is that when a ray of light getting incident on the reflecting surface of a concave mirror is actually passing through the principal focus, after reflection it becomes parallel to the principal axis. It becomes parallel to the principal axis. So this is the reflected ray. This will be the incident ray. Here it is m dash is the concave mirror. So we can write down here light ray passing through principal focus of mirror. After reflection it becomes parallel to the principal axis. Moving further, for the fourth rule, need to draw the basic ray diagram. Draw the concave mirror. The bent out surface is the non-reflecting surface, and the bent in surface is the reflecting surface for concave mirror. Extend the part into a sphere. Center of curvature, pole, principal focus, x dash the principal axis, m dash the mirror. Now the rule is that when a ray of light getting incident obliquely towards the pole of a concave mirror, the light ray get reflected obliquely as per law of reflection. So here it will be angle of incident, here it will be angle of reflection. So we can say that incident light ray falling obliquely at the pole of mirror, the reflected ray will get reflected obliquely as per laws of reflection. So these are the 4 rules that we have to obey while understanding the different cases of concave mirror when the object is placed at different positions. Now let us take the first case. So the topic is now image formation by a concave mirror. When the object is placed at different position. So begin with the first case. Here we have the first case. So first that we need to draw the general structure of the ray diagram. Principal axis, concave mirror, the non-reflecting surface, center curvature, pole, principal focus. Here the object, when an object is placed between C and P, when an object is placed between F and P, that is principal focus and pole, a ray of light touching the head of the object or touching the object which is parallel to the principal axis. After reflection from the reflecting surface of a concave mirror, it passes to the principal focus. Another ray of light, another ray of light which is passing through the center of curvature, touching the head of the object. After reflection, it reverts back on the same path. Now, if these two rays extend further, these two rays appear to meet somewhere behind the mirror. So, here it will be A, B. This will act as an object. Here it will be A dash, B dash. It will be the image. This line X and X dash is your principal axis. So I will consider that this will be image and this will be your object. So we can see that we have placed the object between pole and principal focus. And what about image? Uh, where the image is formed, we can see that image is formed behind the mirror. And what about the size of image? We can see the image size is enlarged when I compare with the object, and the nature is virtual and erect. Moving further, in case 2, draw the basic structure which is required for ray diagram. We need to draw the concave mirror. Here it is the non-reflecting surface. Encircle it to make a sphere of which the mirror is a part. Center of curvature, principal focus and pole. Now we need to place an object at focus. So before that we need to draw the principal axis X, X dash. Here when the object is placed at principal focus, a ray of light getting incident on the reflecting surface touching the head of the object, and it is parallel to the principal axis. So this line ray is parallel to the principal axis. After reflection, it passes to the principal focus. Another ray of light passing through the center of curvature, touching the object and getting incident on the concave mirror reflecting surface. It reverts back on the same path. So these rays will meet at infinity. So image formation will be at infinity. So what we have done, we have placed the object at principal focus. And what about image? Image is formed at infinity, and the size of image is highly enlarged. The image will be highly enlarged, and the nature of the image is real and inverted. If we get the image somewhere at infinity, in what way we get? We get somewhere below the principal axis, and it will be inverted, and it will be a real image. We can just locate the object A, B, and we can just locate the image as A dash, B dash. So this will act as image, and this will act as object. Now moving further for case 3. So here we have the ray diagram for case 3, concave mirror. Here is the center of curvature, here it is principal focus, and here it is pole. X dash is the principal axis, M dash is the concave mirror. Now we need to place the object somewhere between center of curvature and principal focus. Object placed between center of curvature and principal focus. So here it is placed. This will be object AB. So when a ray of light touching the head of the object parallel to the principal axis of getting incident on the reflecting surface of concave mirror, it passes to the principal focus of the concave mirror. Now another ray of light getting incident on the reflecting surface of a concave mirror but passing through the center of curvature touching the head of the object, after reflection it revert back on the same path. So these two rays will meet somewhere here. So this will be A dash B dash, this will be A B, this represent image, this represent object. So we can see that the image formed is real and inverted. So let us write down the image formed here is enlarged. Enlarged image is formed. The image is real and inverted. And what is the position of image formation? Image is formed beyond center of curvature. Now moving further, after case 3, case 4, draw the basic structure of the concave mirror of principal axis. This is a concave mirror. Concave mirror is a part of a sphere. This is center of curvature, principal focus, and pole. X dash is the principal axis, M dash is the concave mirror. Now we need to place the object at center of curvature. Now we have a ray of light which is touching the head of the object parallel to the principal axis. After reflection from the concave mirror, it reflected to the principal focus of the concave mirror. Now another ray of light which is coming from the source touching the head of the object and passing through the principal focus and getting incident on the reflecting surface of concave mirror. It gets reflected and becomes parallel to the principal axis. Now we can see these two rays used to meet somewhere here. So here the image formation will take place. So it is A dash B dash, and here it will be A B. This represent object and this represent image. So what we have done, we have placed the object at center of curvature. What about image? Image is formed at center of curvature. Image, we can see it is of same size as the object size, and it is also a real and inverted image. Now we have case 5. In this case we need to place the object beyond C. So we need to draw the basic structure of concave mirror. Here we have drawn the concave mirror, and this represent a concave mirror. Here we have center of curvature, P pole, and this one is principal focus. Place the object beyond C. A ray of light touching the head of the object parallel to the principal axis passing through the principal focus of the concave mirror. Another ray of light touching the head of the object. This ray of light is passing through the center of curvature. So when the ray of light passing through the center of curvature, it getting reflected on the uh, reflection surface, and it get reflected on the same path. So these two rays meet somewhere here. This will be the object image A dash B dash. This will be A B. This represent object and this represent image. So we have placed the object beyond C, that is beyond center of curvature. And what about image? Image is formed between C and F. The image size is diminished, and image size is diminished with real and inverted nature. So this is case 5. Now moving further, the last case of this concave mirror, case 6. We need to place the object somewhere at infinity. So we have drawn a concave mirror. This represents a concave mirror. Now here the center of curvature, F principal focus, and P is pole. We are placing the object at infinity, A, B. This represent object. Ray of light touching the object and parallel to the principal axis. After reflection from the concave mirror, it passes to the focus. A ray of light parallel to the principal axis. After reflection, it passes to the principal focus. So image formation will take place at principal focus. The image will be very small, A dash B dash. Where the object is placed at infinity. And what about image? Image is formed at principal focus, and the image size is highly diminished, and image is nature is real and inverted. So these are the different cases we come across for concave mirror.